Hey everyone, and welcome. You're actually interacting with AI agents all the time, whether it's your smart home devices or the massive systems that kind of run our world. They are the absolute core of how AI can see, think, and act. So in this explainer, we're going to break down exactly how they work from the most basic all the way to the truly brilliant. So let's kick things off with a question. What on earth could a simple thermostat possibly have in common with a super advanced, fully automated smart factory? I know, it sounds a little weird, right? But the answer is the key to understanding, well, everything we're about to cover.
And the answer is, they both rely on AI agents. At its core, an AI agent is just an entity that can sense its environment, like the temperature in a room, and then take action to hit a specific goal, like making that room comfortable. This idea right here, it's our fundamental building block.
To really wrap our heads around this, we're going to start at the very beginning. We're talking about the foundational agents that are all about instant reaction. These are the basic reflex agents. Okay, so this infographic right here is going to be our roadmap for this journey. Let's start over on the left with the first two types, the simple reflex agent and the model-based reflex agent. They look pretty similar, but trust me, there's one critical difference that changes everything.
All right, first up, the simple reflex agent. This is as basic as it gets. It literally lives in the right now. It senses something and immediately follows a simple if-then rule. Just think about that thermostat. If the temperature drops below 70 degrees, then turn on the heat. That's it. It has zero memory of what the temperature was even 5 minutes ago, only what it is in this exact moment.
Okay, but what happens when we give our agent a memory? Well, then you get a model-based reflex agent. This one keeps a little internal model of its world so it can track what's happened in the past. So a little robot vacuum doesn't just see a chair leg in front of it. It remembers the other chair legs it's already gone around. Being able to track the past like this lets it make way smarter decisions, especially when it can't see the whole picture at once.
So it all boils down to one thing, memory. The jump from a simple reflex agent to a model-based one is all about adding that internal memory. One just reacts to the now, while the other can actually consider the past. And that single upgrade makes an agent so much more effective and adaptable. It's a huge step up.
But reacting isn't always enough, right? What if an agent needs to be proactive? What if it needs to work towards a specific objective? Well, that brings us to the next level of sophistication, agents that have a goal. Let's jump back to our guide for a sec. You can see the next step in the evolution right here. We're now moving into goal-based and utility-based agents. This is a huge leap because now we're talking about AI that starts to think about the future, not just the past and present. It's the shift from pure reaction to actual strategic planning. Think of a goal-based agent as having a single-minded mission. It's got a destination in mind. It doesn't just wander around bumping into things. It plans out a whole sequence of actions to reach its objective, like a navigation robot trying to get to the kitchen. It'll actually think about different paths and choose the sequence of turns that gets it closer to that goal. It's thinking ahead. But then we get even smarter with the utility-based agent. This one doesn't just want to reach a goal. It wants to get there in the best possible way. And it does this by assigning a utility, basically a happiness score, to different outcomes. A self-driving car's goal is to get you to your destination, sure, but a utility-based agent in that car is balancing trade-offs, like speed versus safety versus fuel efficiency, to find the route with the best overall score. And this is what's so cool. The question the agent asks itself completely changes. A goal-based agent is just asking, will this action get me there? It's a simple yes or no. But a utility-based agent, it's asking, which action is the best one, all things considered? The outcome isn't just success or failure anymore. It's graded on a scale of how good it is. That's a massive leap in intelligence. Okay, so we've seen agents that can react, agents that can remember, and agents that can plan. But what about the Holy Grail? An agent that can actually improve itself. This brings us to the top of the mountain, the agent that learns. And that brings us to the final evolution on our chart, the learning agent. This thing doesn't just follow its programming or its plans. It actively gets better at its job over time by adapting based on feedback and experience. This is the real game changer. So how does this magic happen? Well, a learning agent basically has 4 parts, working like a little team. You've got the performance element, that's the part that's actually doing stuff. Then the critic watches what it did and gives it feedback, like a little thumbs up or thumbs down. The learning element takes that feedback and updates the agent's brain. And finally, and this is super important, the problem generator nudges the agent to try new things, to explore, just to see what happens. It's this constant loop of doing, getting feedback, and getting smarter. Okay, so we've met the whole cast of characters: the reactor, the rememberer, the planner, the optimizer, and the learner. But where things get really incredible is when you put them all on the same team, in what we call a multi-agent system. And this brings us right back to where we started, with that smart factory. Our infographic culminates here because a smart factory is the perfect example of how these different agents work together, almost like a symphony, with each one playing the part it's best at. So at the very base layer, you have your simple reflex agents. Their job is critical: safety. If a sensor spots a problem, a reflex agent instantly shuts down a machine. There's no thinking, no planning, just pure, immediate, life-saving reaction. Layered right on top of that, you've got the model-based agents. Using their memory, they're constantly tracking the health of all the machines. They can spot patterns over time and actually predict when a part is about to fail, so they can schedule maintenance before anything breaks down. Then you've got the goal-based agents. Think of them as the project managers of the factory. They're focused on the big picture objectives, like, we need to produce 10,000 units this week. They're the ones creating the high-level plan to make that happen. But just hitting the goal isn't enough, right? You need to be efficient. And that's where the utility-based agents come in. They're the optimizers. They are constantly tweaking the plan, making those complex trade-offs between things like energy cost, raw materials, and production speed to find the absolute best way to operate. And finally, you have the maestro of this whole orchestra, the learning agent. It's analyzing absolutely everything, tons of data from the entire factory, and it's finding tiny inefficiencies that nobody else can see. It suggests totally new ways to improve the entire system for the long haul. It's this beautiful symphony of different intelligences all working together. So when you see how all these pieces can fit together to create these incredibly complex and capable systems, it leads to a pretty big question for all of us. As these multi-agent systems get even more powerful, how are they going to fundamentally change the way that you work, the way you create, and the way you solve problems in your own life? Look, if this stuff fascinates you and you really want to stay on top of how agentic AI is changing everything from products to business strategy, you should absolutely subscribe to the AI Product Management Playbook by Deepak Deo on LinkedIn. It's a fantastic resource for the latest insights. Thanks so much for watching.